Hey everyone, Hugh here from LeetCode. Today, we are solving Leetcode75, merge strings alternately in Java. This problem looks simple, but it teaches a very useful interview habit. When two inputs have different lengths, always think carefully about leftovers and bounds checks. By the end of this video, you will understand the problem visually, solve it first with a two-step approach, and then clean it up into a one-loop Java solution. The problem statement says, you are given two strings, word1 and word2. Merge the strings by adding letters in alternating order. Starting with word1, if a string is longer than the other, append the additional letters onto the end of the merged string. Return the merged string. For example, word1 equals ab, and word2 equals pqrs. The output is apqrs, because word2 is longer, so rs is appended to the end. The constraints are small. Both strings have length from 1 to 100, and both strings contain lowercase English letters. We are given two strings, word1 and word2. The rule is simple. Take one character from word1, then take one character from word2, and keep alternating. If one string finishes early, append the remaining characters from the other string. If word1 is ABC and word2 is PQR, the answer is APQFR. We take a, then P, then B, then Q, then C, then R. Now let us look at the case that usually causes mistakes. If word1 is AB and word2 is PQrs, the answer is APQrs. We take a, then P, then B, then Q. Now word1 is finished, but word2 still has R and S, so we add them at the end. That leftover part is the key detail. The most natural beginner approach is to merge the common part first. Common part means the length of the shorter string. After that, we append the remaining substring from the longer string. So if word1 is ab and word2 is pqrs, the common length is 2. We merge A and P, then B and Q, then we append the leftover rs. Final answer is apqrs. Now let us look at the two-step Java approach. We create a string builder called result. We use StringBuilder because we are adding characters again and again. In Java, strings are immutable, so repeated string concatenation inside a loop creates extra temporary strings and uses extra space. StringBuilder keeps one growing buffer, which is cleaner for repeated appends. Then we calculate min length using math.min. We loop from I equals 0 to I less than min length. Inside the loop, we append word1 character at I and word2 character at I. After the loop, if word1 is longer, we append word1 dot substring from min length. Otherwise, we append word2 dot substring from min length. Finally, we return result dot to string. This solution is correct, but notice that it has two phases. First, merge the common characters. Second, manually append leftovers. That is fine, but we can make it cleaner. Let us dry run the two-step approach with word1 equals ab and word2 equals pqrs. We start with an empty result, and min length equals 2. At I equals 0, append word1 0, which is A. Then append word2 0, which is P. Result becomes ap. At I equals 1, append word1 1, which is B. Then append word2 1, which is Q. Result becomes APEQ. The loop ends because the common length is finished. Now word2 still has characters left from index 2, so we append res. Final result is apqrs. Now in an interview, we can simplify the logic. Instead of looping to the shorter length and then handling leftovers separately, we can loop to the longer length. At each index, if that index exists in word1, append word1 character at I. Then, if that index exists in word2, append word2 character at I. This way, leftover characters are handled naturally. Here is the one-loop Java solution. We create a string builder called result. Then, we calculate max length using math.max. We loop from I equals 0 to I less than max length. Inside the loop, We first check if I is less than word1.length. If yes, we append word1.char at I. Then, we check if I is less than word2.length. If yes, we append word2.char at I. After the loop, we return result.toString. Now watch how this handles leftovers automatically. Again, word1 is Abby and word is Pecures. The max length is 4. At I equals 0, word1 0 exists. So append A. Word2 0 exists, so append P. Result is app. At I equals 1, word1 1 exists, so append B. Word2 1 exists, so append Q. Result is app Q. At I equals 2, word1 2 does not exist, so we skip word1. Word2 2 exists, so append R. Result is appcuber. At I equals 3, word1 3 does not exist, so we skip word1. Word2 3 exists, so append S. Result is appers. That is the final answer. Time complexity is O of n plus m, because every character is appended once. Space complexity is also O of n plus m, because we store the final merged string. In an interview, you can say, I iterate up to the length of the longer string. At each index, I append from word1 only if the index is valid, and then append from word2 only if the index is valid. This naturally handles leftover characters. Common mistakes are looping only until the shorter string ends, calling char8 without checking bounds, and using repeated string concatenation instead of StringBuilder. That is Leetcode75. Merge strings alternately. The main idea is simple. Build the answer character by character, and use bounds checks to safely handle strings of different lengths. Thanks so much for watching. If this helped, like the video, share it with a friend, and leave a comment with the next LeetCode problem you want me to explain. Subscribe to LeetCode for more beginners friendly Java interview practice. This is Huhu, signing off. Keep practicing, and I will see you in the next problem.